The Bic Crystal Ball Pen is one of the most iconic and widely used writing instruments in the world. Its manufacturing process combines precision engineering, high-quality materials, and automated production techniques to ensure consistency and reliability. Ballpoint tip. From carbide powder to precision writing, at the heart of the Bic Crystal Pen is its ballpoint tip, crafted with extreme precision. The ball itself is made from tungsten carbide, a material almost as hard as diamond, ensuring durability and smooth writing. The process begins with carbide powder, which is compressed and sintered at high temperatures to form a perfectly round ball. The precision of this ball is measured at the micron level, ensuring an even ink flow and minimal wear over time. BIC's ink is specially formulated for smoothness, quick drying, and long-lasting performance. The ink must meet strict quality standards for viscosity and flow control to ensure that it delivers a clean, uninterrupted line on paper. Automated production. From components to finished pen, the entire manufacturing process is highly automated, ensuring efficiency and uniformity. The pen consists of three primary components. The barrel, made from polystyrene plastic, offering a lightweight yet sturdy structure. The ink reservoir, a transparent tube filled with precisely measured ink. The ballpoint tip, precisely fitted to regulate ink flow smoothly. Each part is assembled using automatic controls that monitor quality at every stage. The ballpoint tip is inserted into a metal cone with extreme accuracy to maintain writing performance. Once assembled, the pens undergo rigorous quality testing, including writing tests and ink flow analysis, before being packaged for distribution. Since its introduction in 1950, the Bic Crystal has remained a trusted writing tool due to its simple yet effective design, affordability, and long-lasting performance. Its manufacturing process reflects a commitment to quality and innovation, ensuring that millions of people worldwide continue to rely on this classic pen every day. Pencils are among the most widely used writing instruments in the world, with around 6 billion manufactured each year. The process of making a pencil involves multiple steps, from extracting raw materials to shaping, assembling, and final finishing. One of the world's most well-known pencil manufacturers is Faber-Castell, which has been producing pencils for over 200 years. Extraction and processing of graphite, the core of a pencil, often referred to as the lead, is made primarily from graphite, a mineral composed of crystallized carbon. This material is soft and leaves marks on paper when pressed, making it ideal for writing and drawing. Graphite was first mined in 1564 in northern England and has since been used for various applications, including pencil production. Modern pencil manufacturing begins with the mining of graphite from underground or open-pit mines. The extracted mineral contains at least 30% pure graphite to make mining economically viable. Miners use drilling hammers to create holes for explosives, which are then detonated to break apart the rock. The extracted chunks are then transported to the surface, where they are crushed into smaller pieces and ground into a fine, dry powder. This graphite powder is then sent to pencil factories for further processing. In the factory, the primary materials used to create pencil leads are graphite, clay, and water. The ratio of clay to graphite determines the hardness or softness of the pencil lead. More clay results in a harder lead, while more graphite results in a darker and softer lead. The ingredients are mixed in a giant blender to form a smooth paste. Once the mixture is prepared, it is pressed through rollers under an extreme pressure of nearly 10 tons per square centimeter to shape it into thin rods, resembling the familiar pencil leads. However, at this stage, the rods are still soft and flexible. To harden them, they are dried at 120 degrees Celsius for 3 hours before being baked at approximately 1000 degrees Celsius for 45 minutes. This firing process strengthens the lead, making it durable for writing and drawing. Additionally, the leads are dipped into a wax and oil bath to create a smooth texture, allowing the pencil to glide effortlessly on paper. The wooden casing of a pencil is made primarily from cedar wood, chosen for its softness, durability, and ease of sharpening. The wood is cut into rectangular planks measuring approximately 18 centimeters by 7 centimeters by 5 millimeters. These planks are then passed through a grooving machine that carves shallow slots into them. To secure the pencil leads, the grooves are filled with a slightly elastic glue that prevents the lead from breaking inside the wood. The graphite rods are carefully placed into these grooves, and another matching plank is placed on top, forming what is known as a wooden sandwich. This sandwich is then pressed together with 1 ton of pressure and dried in an oven for an hour to ensure a strong bond. Once the glue has dried, the wooden planks go through a milling machine, which cuts them into the desired shape: hexagonal, cylindrical, or triangular, depending on the pencil design. A single plank typically produces about 10 pencils. The pencils are then coated with multiple layers of paint, enhancing their appearance and providing a smooth finish. Next, they pass through a sanding machine, which sharpens them to a fine point. For pencils with erasers, a machine attaches a metal ferrule to the pencil's end before inserting a rubber eraser with pressure. Ink is an essential component in the printing industry, playing a crucial role in producing high-quality prints for various applications, from packaging to promotional materials. The process of ink manufacturing is a meticulous and complex procedure that involves a combination of science, craftsmanship, and passion. Below is a detailed breakdown of how ink is made, from raw materials to the final product ready for use. Ink making is not just a mechanical process, it involves a deep understanding of color science and chemistry. Each ink manufacturer follows a unique philosophy in their approach, often driven by a commitment to making ink that is user-friendly for press operators. The goal is to create ink that ensures smooth printing, consistent results, and vibrant colors. The basic composition of ink is primarily made up of 2 essential components: pigment. This provides the ink's color. The pigment is typically a finely ground powder that defines the ink's shade, such as yellow, magenta, cyan, or black. Vehicle. The vehicle serves as the carrier of the pigment, giving the ink its required consistency. It is a varnish-like substance, often sticky and gooey, resembling honey in texture. Some parts of the vehicle are thick and viscous, while others are more fluid, similar to water. Initial mixing of ingredients. The first step in ink production involves weighing and mixing the pigment with the vehicle. These materials are combined in a pot and heated to achieve a uniform consistency. The heating process helps reduce viscosity, making it easier for the pigment to be incorporated without forming airborne dust. This is crucial to ensure that the pigment is evenly distributed and can flow through the production machinery efficiently. Once the initial mixture is ready, the next step is called grinding or dispersion. This process ensures that the pigment particles are finely broken down and uniformly distributed. There are 2 primary methods used: bead mill. This machine contains numerous small steel balls that impact the pigment particles, breaking them apart. The bead mill provides a rough grind and helps in color development, but does not produce a high-gloss finish. 3-roller mill. Considered the superior method for gloss and smoothness, the 3-roller mill consists of 3 large steel rollers moving in opposite directions. The intense shearing action smears the pigment particles apart, refining them to their smallest possible size. This step is crucial for achieving high color strength and a polished finish. Quality control, QC, and testing after the grinding process. The ink undergoes a series of quality control, QC tests to ensure consistency and performance. Grind test. This test verifies that pigment particles have been sufficiently reduced to ensure smooth and even printing. Bleach test. A small amount of ink is mixed with opaque white to assess color strength. This helps determine if the pigment dispersion is optimal. Tack measurement. The tack or stickiness of the ink is evaluated to ensure it transfers correctly during printing. If the ink is too tacky, it can cause transfer issues. If it is too thin, it may not adhere properly. Addition of extra ingredients. Once the initial QC tests are passed, additional ingredients are introduced to enhance the ink's properties. These may include waxes, to improve rub resistance and durability; dryers, to help the ink dry quickly and form a solid film after application. Other additives, to modify characteristics like flow, gloss, and adhesion based on printing requirements. Color matching and Pantone mixing. While standard 4-color process inks, cyan, magenta, yellow, and black, cover a broad range of colors, they may not be sufficient for specific design needs. To accommodate a wider spectrum of colors, ink manufacturers use the Pantone matching system (MS). By intermixing base colors, nearly any shade can be achieved. Additionally, a specialized color matching lab ensures that custom colors can be precisely created for unique printing requirements. After passing all QC tests, the ink undergoes one final refining step using a 3-roller mill. This step removes any remaining air bubbles and further enhances the ink's gloss and finish. The ink is then packaged into containers ready for distribution to customers. Polyethylene terephthalate PET is a strong, safe plastic, comprising about 96% of U.S. plastic bottles. Initially, technicians load PET pellets into a hopper, either manually or through a vacuum system, where they are transported to the machine. The pellets are then measured and proportioned for the injection process. Inside the machine, the pellets go through a heating and melting process, transforming them into a molten state. Once melted, the plastic is injected into molds in the shape of the desired product. For plastic water bottles, this could be the initial formation of small hollow cones. The molds are carefully designed to ensure precision in the final product. The injection process involves high pressure, allowing the molten plastic to fill every detail of the mold. After injection, the plastic is cooled and solidified within the mold. For items like plastic cups, a robotic arm removes the products from the machine for inspection. Lids and squeeze tops are often produced in one step, with the finished products ejected down a chute. For plastic bottles, the injection molding process is multi-step. The initial formation of small hollow cones allows for easier storage. When an order is placed, these cones are heated, becoming pliable again, and then squeezed into larger molds. Pressurized air is introduced, causing the plastic to expand and take the full shape and size of the bottles. In the context of plastic water bottles, extrusion molding involves squirting heated plastic out into long, hollow tubes resembling large plastic noodles. 3 of these tubes are then molded together. The molds clamp around the plastic noodles, and pressurized air is introduced to expand the plastic into the final shape of the bottle. Heat treatment is a crucial step in plastic bottle manufacturing. After extrusion molding, bottles may undergo heat treatment to improve adhesion for screen printing. The bottles are exposed to fire, enhancing the surface properties and ensuring better ink adherence. This process is essential for creating a glossy sheen on the bottles, contributing to their aesthetic appeal and allowing for effective branding through screen printing or pad printing techniques. Bottles are sent to screen printers for branding, adding names and logos to enhance their appeal. The final step involves sealing the bottles, placing them in plastic boxes and shipping them to customers worldwide. Pens are crafted from polypropylene copolymer, PPC, known for its lightweight, stain resistance, and low moisture absorption. Precise material selection ensures durability and quality writing instruments. Injection molding is a pivotal step in pen production. Polypropylene copolymer, PPC pellets are mixed, measured, and then injected into molds shaped like pen components. The melted plastic fills the molds, solidifying into pen bodies, caps, clutches, and interior barrels. This process ensures uniformity, precision, and efficiency in creating the intricate parts of the pen. After molding, the components are carefully removed from the frames, and any excess plastic, known as the runner, can be recycled to produce more PPC pellets for future pen manufacturing. Ink refilling involves attaching metal nibs to plastic barrels, injecting ink through tips, and twisting for distribution. Testing involves multi-parameter machines measuring refill affinity, wear rate, and ink flow at various speeds, ensuring quality and performance consistency. During assembly, a skilled technician integrates the ink chamber, spring, tip, thrust tube, and push button. Each pen undergoes hand inspection for quality control, discarding any flawed units. The pens are then carefully wrapped in plastic and boxed for shipping. The packaging department ensures secure delivery to customers worldwide, emphasizing the attention to detail and dedication to quality throughout the entire production process. This thorough assembly, inspection, and packaging contribute to the assurance of delivering flawless, reliable pens to users around the globe. The injection molding process at Faber-Castell's Engelhartzell plant initiates the production of highlighters. Highly efficient machines mold plastic components, pen caps and bodies, using cutting-edge injection molding techniques. Notably, a sustainable approach is adopted with an increasing use of recycled plastic for these components. The injected parts undergo a color check to ensure uniformity and adherence to quality standards, setting the foundation for the subsequent stages of highlighter manufacturing. Focuses on formulating highlighter ink. Faber-Castell prioritizes safety, utilizing harmless dyestuffs. The ink mixing process ensures precise color consistency, promoting quality and meeting stringent standards before assembly. Color check ensures precise hues, maintaining quality standards in manufacturing process. The assembly phase unfolds with intricate steps. Processes include printing, ink reservoir insertion, end cap assembly, ink injection, tip assembly, clip attachment, and fully automated packaging. Rigorous quality checks ensue. Printing involves applying brand and product information onto the highlighter's surface, ensuring clarity, durability, and alignment with Faber-Castell's quality standards in the assembly process. The ink reservoir is precisely inserted, ensuring seamless integration for functionality. End cap assembly secures closure. Ink injection ensures consistent highlighter performance. Clip assembly involves attaching the highlighter's clip with precision, ensuring a secure and functional grip, reflecting Faber-Castell's commitment to quality and user satisfaction in their assembly process. Fully automatic packaging ensures efficient and standardized packaging of assembled highlighters. Quality checks rigorously examine each highlighter, ensuring adherence to Faber-Castell's standards. Involves manual packaging, emphasizing precision and care in handling the finalized highlighters. The tip assembly is a crucial step, where the highlighter's writing end is securely affixed, ensuring functionality and durability. This manual process reflects Faber-Castell's commitment to maintaining high standards in the final stages of production. Pen tests involve rigorous evaluations, checking ink flow, color vibrancy, and writing performance. Faber-Castell ensures each highlighter meets high standards for smooth, reliable, and consistent writing experiences. Homemade inks crafted for optimal writing, enhancing personal and creative expression. Engineered for a superior writing experience, ensuring smooth, precise, and consistent results. Individual pen components are rigorously inspected for quality assurance and precision. Beginning with carbide powder, a robust material undergoes processing, resulting in perfectly round spheres with exceptional hardness, crucial for durability. Careful processing shapes carbide powder into flawless, precisely round pen spheres. Spheres exhibit hardness nearing that of diamond, ensuring exceptional durability. Every pen ball undergoes rigorous quality control, guaranteeing perfection and eliminating defects, reinforcing BIC's commitment to excellence in craftsmanship. Advanced manufacturing processes ensure precision and quality in crafting pen points. Micron-level precision guarantees exacting accuracy in manufacturing pen components. Thorough control measures ensure optimal functionality and performance of pen points. Materials chosen with precision to uphold high standards of quality. Advanced molds optimize pen component production, ensuring efficiency and consistency. Stringent quality checks at every stage of production guarantee a uniform and high standard, reinforcing the commitment to consistent excellence. Exemplary assembly process ensures precision and excellence in crafting each pen. Automatic controls implemented throughout production monitor and regulate various stages, enhancing efficiency and precision while maintaining the highest quality standards. A comprehensive system with over 70 controls spans the entire production process, meticulously examining components and ensuring excellence in the finished pen. The initial phase of crafting celluloid fountain pens involves measuring dimensions and attaching, a process that sets the foundation for the entire manufacturing journey. Once the measurements are established, a selected piece of celluloid is cut to the precise dimensions. This marks the beginning of the meticulous process of fashioning the barrel. Craftsmen employ various tools, cutting instruments, and shaping devices to sculpt the celluloid into the desired barrel shape. This manual craftsmanship requires a keen eye for detail and a deep understanding of the material's characteristics. As the barrel takes form, artisans continually check and refine its dimensions to ensure accuracy. The addition of a gradient to the celluloid barrel is a process that adds a layer of visual sophistication to the fountain pen. Carefully blend colors or incorporate intricate patterns, seamlessly transitioning across the surface of the barrel. This intricate detailing not only enhances the aesthetic appeal, but also showcases the versatility of celluloid as a material. The gradient, skillfully applied, contributes to the unique identity of each fountain pen, making it a distinctive and personalized work of art. After shaping the celluloid barrel, the process of sanding commences to refine its surface. Craftsmen use various grits of sandpaper to achieve a smooth and flawless texture. This step not only enhances the tactile experience, but also prepares the barrel for its final finish. Simultaneously, the ends are rounded with precision, combining functional considerations with aesthetic finesse. The rounded ends contribute to the pen's ergonomics, ensuring a comfortable grip for the user. Upon completing the sanding and rounding of the celluloid barrel, artisans focus on finalizing dimensions. Using precise measuring tools, they conduct a thorough examination to ensure the barrel adheres precisely to the predetermined specifications. This stage involves a check for symmetry, proportion, and overall coherence in the design. Adjustments are made as needed to achieve perfection in every detail, maintaining consistency and balance. The careful scrutiny of dimensions is not only crucial for the pen's structural integrity, but also ensures that the celluloid fountain pen embodies the desired aesthetic qualities. Creating the ink view is a delicate and precise phase in celluloid fountain pen manufacturing. Artisans carefully incorporate a transparent section into the barrel, known as the ink view, allowing users to monitor the ink level. This process requires expertise in seamlessly integrating this functional feature while maintaining the overall aesthetics of the pen. The transparent material used for the ink view is often polished to perfection, ensuring clarity and visibility. Precision is paramount during attachment, as any imperfection could compromise both the visual appeal and functionality. Employ specialized tools to carve out grooves with exacting accuracy where the cap will securely attach to the barrel. These grooves are strategically designed to ensure a seamless and snug fit, allowing the cap to effortlessly screw onto the barrel while maintaining structural integrity. Carefully consider the mechanics of the cap attachment, ensuring smooth engagement and disengagement without compromising the celluloid material. The depth and pitch of the grooves are finely tuned, requiring a delicate balance to achieve both functionality and aesthetic harmony. This step also involves shaping the threads of the screw, which demands a keen understanding of the threading process. Each turn of the cap must feel smooth and consistent, reflecting the precision involved in the crafting of these grooves. Pay particular attention to the transitional areas between the grooves and the rest of the barrel, ensuring a seamless integration that contributes to the overall visual appeal. To fine-tune the barrel's diameter, craftsmen immerse the celluloid in boiling water, making it more pliable. This enables them to delicately adjust its dimensions to meet the specified requirements. Extended soaking of celluloid barrels in boiling water is approached with caution, as it can negatively impact ink flow. Prolonged exposure may compromise the material's structural integrity, leading to undesired effects on the fountain pen's performance. Careful monitoring ensures the delicate balance between adjustment and preservation of functionality. Attaching the end of the cap is a process where craftsmen ensure a seamless connection between components. With precision, the cap's end is securely affixed, enhancing both the durability and aesthetic cohesion of the celluloid fountain pen. In the finalizing dimensions stage, artisans review every detail, checking for symmetry and proportion. Adjustments are made as needed to ensure the celluloid fountain pen adheres precisely to predetermined specifications, resulting in a well-balanced and visually appealing writing instrument. Carefully adjust the barrel's inner dimensions to accommodate intricate mechanisms and ensure optimal ink flow. This delicate process requires precision to maintain the pen's functionality while preserving the structural integrity of the celluloid. Specialized tools are employed to achieve the desired internal diameter, contributing to the seamless operation of the pen. The artisans pay attention to the balance between form and function, ensuring that the adjusted internal diameter enhances the writing experience without compromising the overall design. buffing is the final touch in celluloid fountain pen production. Skilled artisans use polishing tools to refine the surface, enhancing the material's luster and creating a smooth, exquisite finish. Attaching the cap ring involves affixing a decorative ring to the fountain pen cap. Craftsmen meticulously secure it, adding a subtle yet elegant detail that enhances the overall aesthetic appeal of the celluloid pen. Attaching the grip to the cap involves securely integrating the ergonomic section that enhances the pen's comfort. Simultaneously, craftsmen attach the nib, a pivotal component that demands precision, ensuring the nib aligns seamlessly with the pen's design, contributing to both function and aesthetics in celluloid fountain pen production. Harumi Tanaka's process of cutting and shaving down celluloid for Hakase fountain pens involves precision and care. Selecting vibrant celluloid sheets, he skillfully sculpts them, ensuring each curve and contour is crafted with attention to detail, resulting in pens that not only function flawlessly, but also boast a visually captivating allure. In the creation of Hakase fountain pens, the collaboration of water buffalo horns and celluloid to form the barrel is a distinctive hallmark of Harumi Tanaka's craftsmanship. Tanaka selects water buffalo horns renowned for their strength, unique patterns, and inherent beauty. These horns, sourced ethically, contribute not only to the pen's aesthetics, but also to their durability. The process begins with the careful preparation of celluloid sheets, chosen for their vibrant colors and durability. The celluloid serves as a canvas for Tanaka's artistic vision, and he expertly integrates it with the water buffalo horns. The combination of these two materials results in a barrel that transcends the ordinary, boasting a seamless marriage of textures and colors. To achieve this harmonious fusion, Tanaka shapes and molds the water buffalo horns to complement the celluloid's contours. The result is a pen barrel that not only reflects the distinctive patterns of the horns, but also showcases the vibrant hues of the celluloid. This integration transforms each Hakase fountain pen into a unique piece of functional art, with no two barrels being exactly alike. The union of water buffalo horns and celluloid not only enhances the visual appeal of the pen, but also contributes to its tactile experience. The pen becomes a tactile delight as the user experiences the smoothness of celluloid and the warmth of the water buffalo horn. Beyond aesthetics, the combination of these materials symbolizes a harmonious blend of nature's elements, connecting the pen's owner to the organic beauty of the world. In the intricate process of crafting Hakase fountain pens, one of the crucial and often overlooked steps is the shaping of the grooves of the screw, a detail that showcases Harumi Tanaka's commitment to precision and functional beauty. The screw, an integral part of the pen's design, plays a vital role in ensuring the secure closure of the cap, but for Tanaka it goes beyond mere functionality. It's a canvas for his craftsmanship. The shaping of the grooves involves a delicate dance between form and function. Tanaka's keen eye for detail comes into play as he carefully determines the size, depth, and spacing of the grooves. Every aspect is considered to enhance both the visual appeal and the practicality of the pen. The precision in shaping these grooves is not only an aesthetic choice, but a testament to Tanaka's dedication to providing an unparalleled user experience. Tanaka uses specialized tools, often handcrafted to his specifications, to create the perfect grooves. Each groove is cut with precision, ensuring that the threads of the screw engage seamlessly when the cap is twisted on or off. This attention to detail not only guarantees a smooth and satisfying user experience, but also extends the longevity of the pen, emphasizing Tanaka's commitment to creating enduring pieces of functional art. The depth of the grooves is carefully calculated to strike a balance between ease of use and the longevity of the threads. Tanaka considers the material properties of celluloid and water buffalo horn, ensuring that the grooves are deep enough to provide a secure grip while avoiding any compromise to the integrity of the materials. The result is a screw mechanism that is not only efficient but also resilient, standing the test of time without sacrificing the pen's aesthetic appeal. The spacing of the grooves is another nuanced aspect of Tanaka's craftsmanship. Evenly spaced grooves contribute to the visual harmony of the pen, creating a sense of balance and proportion. Beyond aesthetics, the spacing influences the tactile experience of opening and closing the pen. Tanaka adjusts and refines the spacing to achieve the optimal feel, ensuring that every twist of the cap is a tactile delight for the user. Selecting the appropriate nib is the first step in this intricate process. Tanaka offers a variety of nib options, recognizing that different individuals have unique preferences for their writing experience. Whether a fine, medium, or broad nib, each is chosen with the utmost care to meet the specific needs and desires of the pen's future owner. Once selected, the nib undergoes a transformative journey under Tanaka's skilled hands. Using specialized tools, he shapes the nib with precision. Considering factors such as size, shape, and flexibility, the goal is to create a tip that glides effortlessly across the paper, providing a smooth and consistent ink flow. The shaping process extends beyond mere functionality to encompass a personalized touch. Tanaka takes into account the user's writing style and preferences, ensuring that the final product becomes an extension of the individual. Whether a writer prefers a more flexible nib for expressive strokes or a sturdier one for precision, Tanaka's craftsmanship caters to these nuances. Each nib is hand-shaped, a testament to the artisan's commitment to traditional craftsmanship. Tanaka's skill in manipulating the metal nib reflects years of experience and an innate understanding of the symbiotic relationship between the writer, the pen, and the paper. The result is a nib that not only meets the technical demands of a fountain pen, but also resonates with the user on a personal level. The first consideration in fashioning the cap is the selection of materials, a choice that reflects Tanaka's dedication to quality and innovation. Employing the same celluloid and water buffalo horn combination used in the barrel, Tanaka ensures visual harmony and continuity throughout the pen. The celluloid contributes vibrant colors and a smooth finish, while the water buffalo horn adds strength, durability, and distinctive patterns. The process begins with the careful shaping of the cap, ensuring it complements the overall design of the pen. Tanaka's skill in manipulating the materials becomes evident as he sculpts the celluloid and water buffalo horn to create a cap that seamlessly integrates with the pen's aesthetic. This stage involves intricate detailing, where every curve and contour is crafted to achieve a visually pleasing and balanced result. The patterns and textures on the cap are not arbitrary. They are a deliberate expression of Tanaka's artistic vision, whether incorporating subtle marbling effects or showcasing the natural beauty of water buffalo horn. Each cap becomes a unique piece of art, reflecting the individuality of the materials used. The cap's design often echoes elements present in the barrel, creating a harmonious visual connection between the two main components of the pen. Beyond aesthetics, the functionality of the cap is a paramount consideration. Tanaka ensures a secure and precise fit, allowing the cap to protect the nib and maintain the pen's integrity during storage. The cap is meticulously engineered to provide a snug closure, preventing ink from drying out and maintaining the pen's readiness for the next use. Tanaka's commitment to functionality ensures that the cap not only enhances the overall design, but also serves as a practical and integral component of the Hakase fountain pen. Customization is another hallmark of Tanaka's cap fashioning process. Clients have the opportunity to personalize their pens with engravings, adding a further layer of individuality to the cap. These engravings can range from initials to intricate designs, making each Hakase fountain pen a bespoke creation that tells a unique story. After crafting the Hakase fountain pen, Harumi Tanaka's final touch involves turning the pen to check the smoothness of the barrel. This ritual is a crucial step in ensuring that every curve and contour feels seamlessly integrated. Tanaka's experienced hands delicately assess the tactile experience, confirming that the pen glides effortlessly, delivering a writing instrument that not only delights the eyes, but also offers a superior and smooth performance in the hands of its discerning owner. The pen's culmination occurs as Harumi Tanaka attaches the carefully crafted nib, a process that marries precision and functionality. Subsequently, Tanaka tests the pen, ensuring the flawless execution of every detail. This final examination guarantees that each Hakase fountain pen not only boasts artistic allure, but also delivers an exceptional writing experience, meeting the highest standards of quality and craftsmanship. The process of mixing graphite and clay involves blending these raw materials in precise ratios, ensuring a homogeneous mixture that will define the pencil's writing characteristics and quality. Following the graphite and clay mixture, the leads are pressed with controlled force, shaping them into the desired form for subsequent processing. After pressing, the pencil leads undergo a crucial drying phase. This meticulous process eliminates any residual moisture, ensuring the leads achieve the desired hardness and consistency before advancing to the next stages of production, such as firing. The dried leads undergo firing, solidifying them for enhanced strength. For color pencils, a specialized step involves immersing the leads in a wax bath. This coating not only enhances the vibrancy of the colors during writing or drawing, but also provides a smooth and even application. The wax bath adds an extra layer of protection to the leads, ensuring durability and preventing breakage. This process not only contributes to the aesthetic appeal of the final product, but also enhances the overall user experience when utilizing Faber-Castell's diverse range of color pencils. Milling machines intricately carve precise grooves into wooden slats for lead placement. Careful placement as leads are inserted into milled grooves of slats. Slat closure forms a secure sandwich, enclosing leads within the pencil. Drying wheel sets pencil structure, bonding leads and slats for a cohesive and robust unit. Milling machines refine pencil exteriors, ensuring a smooth and uniform finish. Chapter includes precise paint mixing, application, and branding through stamping process. Artful process. Mixing paint involves blending pigments for desired colors, ensuring vibrancy and consistency before applying to the pencils. With a hand, skilled artisans paint each pencil, layering on colors with precision. The strokes contribute not only to aesthetics, but also to a durable and visually appealing finish. Stamping adds essential information, such as brand logos and quality indicators, enhancing the pencil's identity and recognition. Dipping pencils in a protective coating ensures a lasting and resilient finish. Pencils undergo final drying in specialized rooms for a flawless finish. Stringent quality testing assesses each pencil's durability, ensuring they withstand pressures exceeding 2.5 kilogram. Sharpening machines refine tips for a consistent writing experience. Finally, crafted pencils undergo packaging, ready to reach consumers with the assurance of Faber-Castell's commitment to excellence.